Moreover, theory and practicals are not conducted in tandem. So, in theory classes, it was not dealt a particular topic, and it was done in the class. It was done in the practicals, and there was a total mismatch in theory and practice in the conventional lab. Then we move to this virtual portable lab using NICE Unlock Discovery 2. It is 2016 onwards. So where students were used to rig up the circuit, conduct the experiment, do various measurements anywhere, anytime. So now they need not have to wait till the lab opens, and since they used to have the kit with them, they could able to make the measurement anytime, and they could able to analyze the circuit very quickly, and they could able to do many tasks in a single experiment. Assume that they are doing a amplifier, they could able to see the amplification, they could able to see the frequency response, they could able to verify the gain bandwidth product is a constant parameter, all those things. So in a single experiment, since they have the circuit rigged up and they can do the experiment any number of times, so now we could able to do many tasks in a single experiment. And because of this more time available to the students we could able to have more number of experiments per lab course. It is not only 12 experiments, we could able to think of more than 20 experiments, so that student can really understand the proof of all theoretical concepts that are learned in the classrooms. And after portable lab, virtual lab using NICE Unlock Discovery will be launched this year. Now here it is anyone, anywhere, anytime. So anybody can conduct the experiment from anywhere and at any time. Now earlier it was only SIT students can able to access the portable lab. Now it is, we want to make anybody can access it. Only prerequisite to access the virtual lab is you should have zeal to conduct the experiment, and you have to know, you have to be very hungry of trying to see what is the variance of various parameters of the circuit diagram. And you can do many experiments at a time. It's not that, okay, you rig up the circuit, you spend time in getting the output. Now we can do many experiments at a time. This actually builds the confidence to student that, okay, I can also conduct the experiment. I know, okay, how does the circuit performs, and what are the type of input I should give, and how does the output look like. And it is easy to access to understand the working of the circuit. Now you can easily understand the working of the circuit. Now let us see why this virtual lab is. So assume that a student wants to conduct an experiment in a conventional lab, so he should be actually enrolled to that particular lab. Otherwise, he is not allowed to use that lab. If it is a portable lab, if a student wants to conduct an experiment, he needs to have a nice Unlock Discovery board. He has to have the components, and he should have a personal computer to conduct a particular experiment. If it is virtual lab, he can actually do any experiment. If he simply has a PC or even a smartphone, he can able to conduct an experiment. If he wants to take readings, so in a conventional lab, it's a tedious process using meters and CROs. So you have to take down readings, which is a tedious process. When it comes to portable lab, using waveforms, you can very comfortably measure many parameters. You can make a number of measurements very efficiently. It is same in case of virtual lab. Assume that if a student wants to conduct many experiments quickly, so he has already done experiment once, he wants to just glance through all the experiments. It's not possible in conventional lab. It's not possible in portable lab also, but he can certainly do in this virtual lab. So during the conduction, suppose if he wants to vary many parameters, now since he is doing many experiments at a time, it's not possible in the conventional lab or even in the portable lab. Whereas in virtual lab, we are providing that facility of varying many parameters in any experiment he is trying to do it over there. During the conduction, if he needs any help in design or the circuit performance, most of the time in conventional lab, faculty members may not be available. He will not be getting the support, and even his students, friends may not be knowing it. So he'll be denied with the design and the circuit performance analysis. Even in portable lab, it is the same thing. But in virtual lab, since videos are there, he can certainly have a look at it, and then he can get the concept of each and every circuit in terms of design as well as the circuit performance. This is what we are looking for. Okay, why a virtual lab means? Okay, because of these many advantages over the conventional, the portable lab. So it is very important that virtual lab will prove to be a very good tool for students and even for faculties to have a glance of all the experiments. So this is how a virtual lab at SIT T looks like. Now these are the users. So users can use a system. He can use his laptop, or even he can use his smartphone. So n number of students or users can connect it through either mobile or system. So the connection will be going to the server which is there at SIT, and we have in telecommunication department so many subsystems which will be connected to n number of circuits through the analog discovery kit. So whenever a particular student wants to do a particular experiment using subsystem 1, he'll be connected to it. Suppose if he wants to use subsystem n, he wants to do some other experiment, he can do it. So this is what the entire picture of a virtual lab at SIT at telecommunication department looks like. And what is, okay, how to use a virtual lab which is there at SIT telecommunication department. First you need to register, then you should log in. There is a video guide to how to conduct the experiment that will be very clearly given, and you're supposed to book a time slot. You'll be getting a username and password of the TeamViewer system, which will be actually used for conducting the virtual lab, and you'll get the access to the subsystem. So once you get the access to the subsystem, you have to select the available experiment for the conduction. So once you're selected, now you have to use the waveform 15 to conduct any selected experiment. So this is the very simple way of using this virtual lab which is there at telecommunication department. So you can very comfortably do these labs. Let us have a look at, okay, what is this waveform 15 is. So if you go to this waveform 15, so this waveform 15 is the major part of the analog discovery, which actually gives a control to the user over the circuit diagram. We know that in order to conduct the experiment, we need to have the power supply, signal generator, and the oscilloscope. This power supply, this is the icon which will going to connect to the power supply, where you can give the required voltage, and WaveGen will actually help to give the required voltage and a particular shape of the waveform. It can be sine, it can be square, it can be even a DC voltage you can apply of any specified amplitude as well as the frequency. Scope is the CRO, like in your conventional lab, where you have a 2-channel CRO which can measure up to 100 megahertz signal. So many parameters can be easily measured over here. The main advantage of this waveform 15 is the network and the spectrum, where students can easily do the frequency response of many circuits in a click of button. So they can do many communication experiments very comfortably, plotting the frequency spectrum of a given particular waveforms. So these are very useful parameters in waveform 15, so that a student can very comfortably conduct the experiment. We have, of course, on a pilot basis, we have done 4 experiments. So first one is Smith trigger. So this is a Smith trigger circuit diagram. So where we have 2 resistors which will decide the threshold voltages. As the input voltage exceeds threshold voltage, so we're going to have the output making a transition from plus V side to minus V side. So the student should be at least knowing, okay, what type of input I should apply and what is the expected output voltage before he starts using this virtual lab. And we also have an analog experiment which is a C amplifier, that is common emitter amplifier, where we have provided a proper potential divider biasing, and we'll apply a very small input voltage, and we have designed it for a gain of 40 and 43 dBs. And a student can apply the input voltage and he can measure the output, and he can also plot the frequency response using the network option that is available in waveform 15. And he can do the Wayne bridge oscillator, which is an op-amp based circuit diagram. So depending on the values of R and C, he'll get the oscillations once the gain of the amplifier is more than 3, which is the theoretical condition required to make the system to oscillate. So he can comfortably conduct the experiment. And this is the PWM generation using a 555 timer, where he'll be applying the modulating signal at the control voltage, so that he can get the output voltage at this output point, which is pin number 3 of 555 timer, whose pulse width will be keep varying as per the magnitude of the message signal. So these are the 4 experiments what we have considered for the PWM generation. If any of, okay, before we actually go to the demonstration of the virtual lab experiments, if anybody has got any doubt, so that I can clarify it and I can proceed to the virtual lab. Sridhar sir, can I just proceed, or shall I get some questions?
Yes, sir, there is one question.
Yeah.
Fundamentally, how is virtual lab differs from simulating and experimenting on the system?
Okay, this is a very good question. As we are telling that this is virtual lab, the students will be actually using the hardware circuit. It is not a simulation waveform. There is the whatever 4 circuits I've just shown over here, they are actually rigged up at my institute, so they can actually applying the input voltage to this hardware. They'll be actually looking at, suppose assume that if you are doing this CE amplifier experiment, actually this hardware is connected in my lab at SIT Tumkur. You can actually apply the required input voltage of whatever frequency you want, and you can physically actually see what is the voltage that is coming here. It's not actually a simulated waveform. It's a hardware circuit to which you are applying a real signal using WaveGen, and you are measuring the output voltage. It's not only one experiment, you can conduct many experiments one after the other, and you can also vary. Assume that here it is 2.2 kilo ohms. During the demonstration, I'll show that I can change this value of resistance also. So by a click of button, the user sitting remotely can able to change this value of resistors and even the frequency, whatever he wants to change. He'll almost have every control as the way how he is doing the experiment at his home or at his lab.
Thank you, sir. Go ahead, sir.
Yeah.
Continue.
Yeah. Let me just go ahead with the virtual lab demonstration. So let me just, as it is said that, okay, to start up with the virtual lab. So let me go to this virtual lab.p.hu. So let me go to, so this is, so I'll be clicking onto that virtual lab p.hu, so which is a website that we have created for the user to use our virtual lab. Of course, for the time being, we have 4 experiments available for any user to use it. So now we are actually logged into that virtual lab. So let us see, okay, what is further we have to do it now. Now this is what we have it for now. Let me register now. So as it was said in the procedure, so once you go to this, so we need to register. So in the registration form, I have to give my email ID. Okay, first I need to sign up. So for the first time you should sign up, give your first name. You have to register your email. Then set a password. Then you say register. This information will go to our lab. So we're going to get a mail regarding. So let me go to my mail. Now I can see I have received account verification. So let me verify what is that I have received. I can see, hello KCN, thank you for signing up. So please click on so and so to activate your account. So I'm now clicking on now. So now it is getting connected to. Now it says that, okay, your account has been activated. Now you say home. Click on home. Now let me just again type the address, okay, email ID, whatever I just given. Let me use the password. Now let me log in. First I have registered. I'm just logging in because it was verified. Now I can book a slot. So I'll book a slot now. So now you're registered. Now I can. Now please check your email for the TeamViewer login ID and the password to start the virtual lab. Only requirement for the user to use this virtual lab is he should have a TeamViewer tool. If he has a TeamViewer tool, he can certainly connect to our virtual lab. Now we have. Let me just see what is. This is. I have received a mail stating that the username and password have been sent. So let me go to. I will use my TeamViewer and use that username and password to connect to the. Now I'm trying to use the TeamViewer. So let me just see what is the. Now I have the number is. It's there. Now let me connect to the partner. So I'll be connecting it to the partner, that is the system to which the actual hardware is connected. The password is now 1371. This is a password. Let me log on. When I say log on, now it's actually connecting it to the circuit, to the system where my hardware is connected. Please see, I'm sitting in a different lab. The hardware is there in a different lab in the same SIT. Of course, anybody can connect from any part of the world to this lab using the username and password once you are registering. I request few of you to register with the. Let me just show you this. I request some of you to log on to this and then register your name so that we can send the username and password of the TeamViewer. Those who have TeamViewer, please go over here and then register your name. So you'll be getting a username and password. Maybe after this presentation, you can certainly make a hands-on with our virtual lab. So let me just continue with the thing what we have. Now this is the screen, the subsystem to which I have connected now to TeamViewer using our virtual lab. Now let me double click on this virtual lab. Now this is, I just came to the virtual lab of our institute. So Siddhaganga Institute of Technology Virtual Lab. Now here we have made options for doing analog experiments as well as digital experiments. Please mind it. This is okay. I'm sitting in a different lab. The actual hardware is there in a different lab. Now I'm connecting to that subsystem using my laptop, sitting at a far off place. Now I want to connect. I want to conduct an analog experiment. I can just click on this analog. Now these are the experiments what we have lined up for today's demonstration. So let me just try to see what are the options available in oscillators using op-amp. If I click on this, now we can see I have the option of using oscillators with frequency 10 kilohertz and oscillator with frequency of 1 kilohertz. This is actually a Wien bridge oscillator. Suppose if I select this one. Now before I actually select this, so one more option I should do it now is, so I had to activate this waveform also. So let me just double click on this waveform. So this is a waveform what I was talking about using the unlock discovery. So as you can see here, so we have this, let me just show you, okay, what are the options that we have in waveform. We have scope, we have wavegen, we have supplies. Now these are the three major icons that what we'll be using very often. So since all the circuits require a plus VCC and minus VCC, let me select this supply. Now, so since the supply is off, I can just switch on the power supply. You can see there is a plus 5 and minus 5 volts are enabled to the circuit now. So let me also have a scope now. Scope is like having a CRO like structure. Now this is, you have the scope and this is the, okay, let me just turn on the scope also. Now let me go back to that virtual lab and try to conduct the experiment of the oscillator. So let me just go to that virtual lab where I had, this is the virtual lab now. So let me try to conduct the experiment using oscillator, which is giving a 10 kilohertz oscillations. Now I'll click on this 10 kilohertz oscillation. Okay, now I clicked on 1 kilohertz oscillation. You can just have a look at, okay, what's happening in waveform. Let me just show you that waveform thing. I'll show you. So I can see now, this is the waveform. Let me just slightly change the volts per division. Now for an oscillator, there is no input required. Usually channel 1 is connected to input. I'll just disable the input. Please make sure that I'm actually conducting an experiment sitting at a remote place. The circuit is there in a different lab. Now I'm actually conducting the experiment. So the hardware is there. I have selected using the selection process here. So I have actually selected, see here, I have selected a 1 kilohertz signal. You can see that that's what you are getting now. This is your, you can actually find out the frequency of this signal. So what I'll do, you can go to this waveform and you can go to this view. Now this is the possibilities of waveform. You can actually select this view and you can actually measure the frequency of. Okay, you can see here, you can measure it. So I can measure what all things you can measure. We can measure so many parameters. So let me go a define parameters. Since it is channel 2, let me select channel 2. Since it's a horizontal parameter, which is a frequency, let me select this frequency. Now we can see we actually selected this for a 1 kilohertz oscillations. Now we can see we are getting almost 891 hertz signal. So which is almost very close to that desired frequency. And let me just change this from 1 kilohertz to 10 kilohertz. Again, I want to repeat. I'm changing this. I will click this on 10 kilohertz. Now you can see the frequency has changed. I didn't change anything over there. So upon clicking this, there is a controller which will be changing the corresponding values of R and C, which will generate a frequency of 10 kilohertz approximately. Now you can see I'm just changing my waveform thing. Now you can see I can comfortably measure the frequency of this oscillator, which is now at 7.5 kilohertz. Of course, even it is 10 kilohertz, because of tolerance in the resistors, I'm getting 7.5 kilohertz as the output. Now this is like, okay, conducting an experiment where you are not supposed to give any input voltage. Let us try to conduct an experiment where you are supposed to give an input voltage. Let me go back to home. Home means again you have this analog as well as digital experiments. I can again select the analog circuit. Let me select a pulse width modulation circuit. Sir, I can stop now here. If I have any questions, I can just answer and I can proceed with the next experiment. Sridhar sir? Hello. Hello. Okay, let me proceed with the experiment of sir.
Yes, sir. Tell me, sir.
If there are any questions, I can answer. Otherwise, I can proceed with the.
You can proceed, sir. Not at this point. No questions, sir.
Okay. Okay. Next, we shall see an experiment where an input voltage is also required to be applied to see the proper output waveform. Now we are conducting a pulse width modulation circuit. Now this is a 555 timer based pulse width modulation where we have rigged up a circuit to generate the carrier signal using the stable multi-operator. Now what I'll do, so let me just make the carrier frequency of the stable as 100 kilohertz. So now the steps are also given. Now steps to be taken before you see a proper waveform. So you have to apply a sine wave of 2-volt amplitude with the offset of 2 volt with a frequency of 500 hertz. Now these specifications will be given so that student can easily understand the working of the circuit and he can able to apply a proper signal. Now let me select the wavegen where I can apply the input voltage. It was said that okay, you have to apply a 500 or any frequency which is of lower frequency. I'm applying a 200 hertz signal. So let me apply a 2-volt amplitude with an offset of 2 volt. Now I have applied a 2-volt offset, 2-volt amplitude and a 200 hertz signal. Now it is being applied. So let me go back to scope and try to see the waveform. I want to scope. Now I have applied. Now since you're not conducted, now you're not pressed this conduct experiment. It is showing actually the previous experiment. That's an oscillator. What I'll do, I'll click on this conduct. Now you can see I'm getting the waveform corresponding to the PWM waveform. So what I'll do, so I have to adjust that x-axis. Now I'll make sure that so I'm getting, because the frequency of the signal is 100 hertz. So let me see the input also now. Now you can see I'm seeing the input. Let me make the volts per division also properly visible so that I can able to see. Now let me. I can see I can actually stop the waveform. I can stop the waveform. I can comfortably see the width variation. Now you can see the width is keep on increasing during the positive half of the modulating signal. The width is keep on reducing during the negative half. You can see it is reduced too much because the amplitude is more. What I can do, I can actually change the amplitude level. Instead of 2 volt, I can make it 1.5. Now these variations I can do it sitting at my place. I'm actually changing the circuit values which is actually running in the other lab. So let me, now I have made the input voltage different now. So now let me again run this. I had this loss of signal. Now you can see I'm getting it properly. Now we can clearly see the width is keep on reducing during negative half. The width is keep on increasing during the positive half of the modulating signal. So this way we can actually have the control over the complete signals which have been applied to the circuit. So now the corresponding circuit of this is actually shown in the it was shown in This is the actual circuit. So this circuit is actually rigged up here, and we are applying a sine wave of specific amplitude and offset with a. Now this is a simulation figure, but actually you have an hardware. So we have actually connected a hardware, and that hardware output we are actually seeing it now. Suppose if I take out the input voltage, suppose if I just go back to my circuit, and if I make the input voltage, what I'll do, I'll just stop this input voltage. You can actually see what is the output is. Since I not applied any input voltage, now it's a pure carrier signal. You can actually see this is a 10 kilohertz carrier signal without any width variation. Suppose if I apply the signal, now you can see there is a width variation. So this way, once the student has understood conceptually how it works in the classroom, he can use our virtual lab n number of times. He can make lot of variations in the input voltage as well as in the circuit parameters. You can also go back to the circuit and try to change the carrier frequency. I have the option of changing the carrier frequency. What I'll do is I'll go back to previous page. Let me go back to previous page and try to. Okay, now let me just go back to home. Again, this pulse width modulation. Now I can change the frequency from this to a different frequency. Now let me select this frequency. When I say conduct the experiment, now I can see I have a different waveform. It's the same circuit. Now we have given the option for the student to change the parameters. Now actually the hardware is changed. So once you click on this particular icon, so whatever icon we have over here, suppose if you click on this conduct experiment, so now it will be conducting for a 500 kilohertz carrier signal. If you go back and try to do it for now let us try to do it for a Smith trigger. So let us apply. Now for a Smith trigger, you have to use the wavegen to apply the input voltage, which is of whose amplitude should be more than the threshold voltage, and let the frequency be even less than 1 kilohertz. Now let me just say conduct. When I say conduct, actually I'm getting. Now I'm not getting the transition happening because the output voltage is at minus V sat. Why it is not happening is because the input amplitude is not exceeding the threshold voltages. So let me make it 5 volt input voltage. What I'm doing, I'll make it 5. Let me make the offset 0 because offset is not required for this particular experiment. Now a student should at least have the minimum knowledge of okay, what type of input to be applied, what type of frequencies to be set. Of course, for each and every experiment, we will be providing a default video which will help the student to understand okay how to conduct the experiment. So since we have applied a 5 volt amplitude sine wave with a 200 hertz without any offset, let us see what is the output now. Now we can see there is a transition happening at the output. Now, if you want, it is also possible to see the hysteresis of this plot, which was, of course, now you can see within 5-10 minutes we could able to conduct 3 to 4 experiments very comfortably. I can see the hysteresis. Just say add xy. Now you can see you're seeing the hysteresis. Now you can see you can measure what is the upper threshold voltage. You can find what is the lower threshold voltage. Student can actually make lot of measurements down here. But they can also take a cursor and then they can actually measure what are the voltages at each and every point. So this way, students can very comfortably conduct any experiment for that matter. Of course, those experiments should be a part of the virtual lab, and whatever variance that is possible in the virtual lab, we can certainly conduct. So in our virtual lab, for the time being, on a pilot basis, we have implemented these 4 experiments. Of course, we can also conduct an amplifier experiment where we have a CE amplifier as well as CS amplifier. So we have done it for only C amplifier, where you can select a gain of 40 dB or 43 dB and your top line, an amplitude of very small magnitude using that wave gen, and you can see the output waveform. So this way, if you are interested in doing any experiment, if you know the theory of that any experiment, and if you want to, even if you're not conducting the experiment, if you want to see, okay, how does the output will look like for different values, we have this virtual lab available to any of you, so that you can simply log into our website, you can just note down this. So this is okay. I have received mails from Parthik. Shall I send? Okay, I'll be sending the email, okay, user ID and password to Mr. Pratik. So please, Pratik, you can just try out our. Of course, first we'll give it for Pratik for half an hour, and maybe even after the webinar, I want to just give it to CP Jain. So we'll be giving it to CP Jain by around 4:30. From 4:15 to 4:30, Parthik can try out our lab. Karthik, you can just you'll be getting a mail from my administrator regarding the username and password of our virtual lab. Okay, so once the students are done with these type of things, they can comfortably do any experiment. They'll have a lot of confidence in, because they can repeat the experiment a number of times. They need not have to remember anything. This is what we can do. So in conclusion, I can say this virtual lab at SIT TE is designed to help the students and even the faculties to access the practical laboratory at any time, so that learning can be done more efficiently, and you can review many experiments very quickly. Of course, I should acknowledge my students, Chetan. So I have been blocked usage of this one. So Pramod, Rakshit, and Naveen Sankar. Of course, I should also thank my students Ankit and Shaurya for their help in making this possible. I thank all of you for listening to this webinar. I again invite all of you to use our virtual lab, which is there available on this address. Of course, we'll be adding many features to this virtual lab, so that students from anywhere of the world can effectively use it. This will be actually coming on our SIT official website in a month or two, so that student can effectively use this virtual lab for improving their performance or understanding the concepts.
Thank you, sir.
Yeah, if I have any questions, I am ready.
Yes. Waveform 15 software, is it a licensed software?
No, it's freely available, so anybody can easily download, and that is not necessary for the user to download at his site. What he needs is only just a team viewer. So if he has team viewer, he can certainly do it. So waveform is not a necessary tool to be installed at his place.
How are multiple students scheduled?
Now, as I just showed this conceptual block diagram of our, I'll just come to that. Now, this is what the a server will take care of. So when I say subsystems, there are so many dots. We plan to have at least 20 such systems available. And since we are giving a slot of only 1 or 1.5 hours for a student, since it is 24/7, since it is automatically allocated, and will be giving the slot for the student, now there will be no overlap among the students to use this virtual lab. So it will be coming very systematically, of course, very soon.
What are the requirements to start virtual lab in department? Is there any special software and permission required?
No such permission required. So if you want to use our virtual lab, only thing that is required is you should have a system and a system with a team viewer along with the internet connection.
Can you demonstrate the resistor component changing virtually?
Yeah, the one which I showed, the frequency of the Wayne bridge oscillator changed from 7 kilohertz to something like 70 kilohertz. It's actually, I just clicked on that button. So where I was, there was two selection of frequencies. One is 10 kilohertz, other is 1 kilohertz. When I say 1 kilohertz, the controller will connect in the hardware a particular resistor which is responsible for generation of 1 kilohertz. When I say 10 kilohertz, the corresponding circuit will be connected. So that will be done purely automatically. So no human is sitting whenever you click that particular option.
What are your plans to increase the number of available experiments?
We will going to make all the experiments of analog circuits starting from rectifiers till the FM demodulation, so on. So it just covers the entire, usually the second year undergraduate students. We start from rectifier, clipping circuit, clamping, amplifiers, triple fire timer related, op amp related, because it just requires, we need to switch the circuit. So we'll make it all possible circuits for all the students.
Is this compatible with all versions of TeamViewer?
Yeah, there is no problem with any version of the TeamViewer. Is it compatible with? Yeah. So it's compatible with any TeamViewer version.
Are there any plans to add features so that users can design their own experiments?
We are thinking of, so of course our aim is to make it like, okay, in simulations, so you have the option of changing the resistor values. Here at presently we don't have too many options. We have given only 2 or 3 options. Now in future what we want to make is whatever we want to make a bank of components. If a student select that particular component, that should be sitting in that particular place. So we are thinking of implementing that.
Thank you very much, sir. Those are all the questions. I will send you the recording right tonight.
Sure. Okay.
Thank you, sir.
Yeah, thank you very much.
Yes, I'll close it.
Fine. Thank you. Easy.